Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the All This Math YouTube channel. Make sure you like the video, drop a comment below if you feel inclined, and share this video with somebody. I also want to give a shout out to Dr. Martin Luther King, who, of course, was a well-known civil rights activist, and I would actually say a human rights activist. But keep in mind, he wrote 3 books. All right, so if you really want to familiarize yourself with King and King's work, reference his 3 books. His first book, I believe, was entitled Strive Toward Freedom, which was written after the Montgomery bus boycott of 1955. Second book, Why We Can't Wait. I don't recall what date that was published or what year that was published. Third book, Where Do We Go From Here? Chaos or Community. All right. So 3 books written by Dr. King himself. Dr. King did a lot more than just deliver the I Have a Dream speech in Washington, D.C. at the March on Washington in 1963. All right. He also did a lot of work between 1963, August 28th, March on Washington, and 1968, April 4th, when he was unfortunately assassinated. All right. He did a lot of work in between those two dates, and we should really study his work then. Also, his protest of the Vietnam War, which he wrote a very epic speech in 1967, which addressed that. All right. So he was not a warmonger. He was not in support of warmongers. Keep that in mind. All right. So what we about to do today? We're about to do some work with fractions. We're about to add 2 fractions together. Negative 3/14 plus 5/7. Before I do fraction problems, fraction arithmetic problems, I like to first keep in mind and highlight what actually a fraction represents as a concept. All right. So what is negative 3/14? All right. Well, let's not even talk about the negative part. Let's pretend the negative sign is not there. It is, but we're gonna pretend it's not there. Let's talk about 3/14. That means that we have an object. It could be a circle, a square, a rectangle, whatever, but it's divided up into 14 equal pieces. That is what the denominator means. The denominator means you got an object that's cut up into 14 equal pieces. Emphasis on the word equal, heavy on the word equal. All right, not this piece real big and the rest of the piece is little, and then what I'm saying. Nah, like fractions and mathematics is about equality. All right, it's about fairness and equality. So the denominator tells us that we have 14 equal sized pieces. The numerator tells us that is how many pieces we are focused on. That is how many pieces we care about. That's what we dealing with. We're dealing with 3 of them. Now, because this is negative, let's bring the negative back into the mix. Because this is negative, that means we owe that many pieces. We may not have them, but we may owe them, or they may be subtracted from the other fraction. Because we could just change the order around and change this into a subtraction problem, and it would be 5/7 minus 3/14. All right, so that's called the commutative property. With addition, we can use the commutative property when we switch the order around of the numbers. Even if they're fractions, we can still use the commutative property. All right. Anyway, let's look at 5/7. The other add-in. These are called add-ins. Things are being added together. They're called add-ins. Add-ins. This is the add-in. This is the add-in. All right. So 5/7. It means we have an object that's divided up into 7 equal pieces, and we are focused on 5 of those. All right. So imagine a cake. It's cut into 7 equal slices. And let's say we ate 5 of them, or we want to give away 5 of them. That's what 5/7 represents. All right. Now, we cannot add or subtract unless we have common denominators. Now, if you ever think about that, you might have heard of that before, but do you ever think about why that is? It's important for you to know why that is. The reason is because the denominator is like a common currency, right? Imagine you had dollars and pesos. Imagine you have $3 and 5 pesos. How are you going to add $3 and 5 pesos together? You can't. You either got to convert the dollars to pesos and then add pesos and pesos, so you'll have a total amount of pesos, or you can convert the pesos to dollars and have dollars and dollars added together and have a total amount of dollars. You can't add dollars and pesos, right? So this is 14, this is 7. Those are 2 different numbers. Because those are 2 different numbers, we can't add. We also can't subtract. We can multiply or divide, but we can't add or subtract when our denominators are not the same. So we need to make these denominators the same. Now, some people, what they do in order to make the denominators the same is they just multiply the denominators by each other. So somebody might look at this and say, oh, watch this. I'm about to just do 14 times 7. Because people like shortcuts and everything, and sometimes multiplying the denominators together is cool. In this particular situation, it's going to cause more problems, even though it's not wrong, but it's going to create a big number for no reason. You don't need a big number for your denominator. if you did 14 times 7, let me break the 14 down into 10 and 4. 10 times 7 is 70. 4 times 7 is 28. 70 plus 28 is 98. We be dealing with 98 for our denominator. And we don't even got to do all that. That's doing too much. We don't got to do all that. You want to think of what is the smallest number that both of these numbers multiply into. What's the smallest number that both 14 and 7 can multiply into, right? That's called your least common denominator. Least common denominator. The least number they have in common that they both can multiply into. That number is going to be 14. How do I know that? Because 14 times 1 is 14, and 7 times 2 is 14. So 14 is the smallest number that they both can multiply into. So this is what I'm going to do. I'm going to create equivalent fractions to this and this. Actually, this is going to stay the same because this already has a denominator of 14. So this ain't going to change at all. All right? So remember, if your denominator don't change, the numerator don't change. This is going to change. So this got to change. This 7 got to change, so this 5 got to change. All right? So I'm just going to rewrite the negative 3/14. And then what I'm going to do is I'm going to change this 7 into a 14. That's my common denominator. Now we got common denominator. But wait, what's going to happen to this 5? That's the key question. What's going to happen to this 5? If I did 7 times 2 to get 14, so it is below, so it is above. So it is below, so it is above. If I multiply by 2 on the bottom, I need to multiply by 2 up top. If I multiply by 2 on the bottom, I need to multiply by 2 up top. 5 times 2 is 10. And now we're ready to add because we got common denominators. We adding up 14ths. That's what we're doing. We adding up 14ths. I want to know how many 14ths do I got all together. That's what I want to know. I can't add 14ths and 7s, right? Just like I can't add dollars and pesos, right? Now I got all 14ths. Well, you can think of it as all pesos. All pesos. Now I can add up all the pesos and find out what's my sum of pesos. So now I do negative 3 plus 10. Now, to do this problem, you got to know how to add and subtract negative and positives. You got to know how to do that. There's a lot of ways to do that. You can think of a number line visually, or you can change the order around and just treat it like 10 minus 3. Positive 10 minus 3. You get 7, right? Or you can think of it as negative 3 plus 10. Imagine a number line. If you're sitting in a classroom somewhere, or you're looking at this at home or somewhere else, but think back into school. If your classroom has a number line on the wall, hopefully it do, and it's got a negative side and a positive side, right? You're starting at negative 3. Imagine you're starting at negative 3 on the number line. Now, whenever you add, you move to the right on the number line. Whenever you subtract, you move to the left. So this is a plus sign. That means we're adding. So that means we're moving to the right. How far though? This many spaces. We're moving 10 spaces to the right. That's what the plus 10 indicates. 10 spaces to the right. So we start at negative 3, then we move 10 spaces to the right. Where we end up at? We're going to end up at positive 7. Just count on the number line. That's one way to do it. So we got 7 14ths all together. 7 14ths. Now, when you're doing problems with fractions, you should always reduce fractions whenever possible. You can't always reduce them, but you can in this case. How do I know I can reduce them? Because this numerator and this denominator have a common factor that is not 1. If the common factor between these two was 1, we wouldn't be able to reduce. That's the test right there. If your common factor between your numerator and denominator is 1, that means you can't reduce, you can't break it down. You can't make those numbers any smaller. You gotta leave it alone, you're done. Pack it up, you're done. All right? But in this case, the common factor between 7 and 14 is 7. So what I could do is I could divide this by 7 and divide this by 7. What's 7 divided by 7? 1. What's 14 divided by 7? 2. So that means your final answer is 1 half. 1 half. Negative 3 14ths plus 5 sevenths is equal to 1 half. Now I know you might be wondering, if we started out with 14ths and 7ths, how do we end up with 1 half? Because we basically cut this up into these sevenths into smaller pieces. 14ths are half of a seventh, right? Imagine you have a pizza. The pizza's cut into 7 slices. If you want to make 14 slices, all you got to do is take each of those 7 slices and cut them in half. Because every one of those 7 slices became 2 slices. So that's how you end up with 14ths, right? So these pieces are smaller. So now we got 14ths and 14ths. So when we combine them, we end up with half, right? That's how we do that. So that's how you add fractions. That's how you find common denominators. And that's how you reduce fractions. All right? Remember what I said. Study Dr. King and get some practice with these problems. I will see y'all on the next video. All right, I'm out.